Okay, here's part 2 of our lesson, starting on quadratic functions, and we're going to graph these functions and label the vertex, axis of symmetry, and y-intercept. So let's figure out what these things are. So if we have y equals 3x squared minus 6x plus 4, which way does it open? The leading coefficient is positive, so it opens up. What's the y-intercept? If you put 0 in for x, you get 4, so it's the point 0, 4. That's the value of c. Let's find the equation of the axis of symmetry. I'm going to call that AOS, axis of symmetry. So we have the opposite of b over 2a. So x equals the opposite of b, 6, over 2a, 2 times 3, 6. So x equals 1 is the axis of symmetry. And then that means that the vertex is going to have an x-coordinate of 1. And to find its y-coordinate, we need to substitute 1 into the equation. So 3 times 1 squared is 3, minus 6 times 1 is 6, plus 4. 3 minus 6 plus 4 is 1. So the vertex is 1, 1. Okay, so let's go ahead and figure out where we want to put our axes. We know we need to go up to 4. We don't have to go by ones on our grid. It just depends on the size of your graph paper and the space you have available. I think I'm going to pretend like that's a straight line. I think I'm going to make this a 1. Okay, so I'm going to plot my vertex 1, 1. Plot my y-intercept 0, 4. Reflect that across the axis of symmetry. We could put that axis of symmetry in here. So if we reflect the point 0, 4 across, we get the point 2, 4. Now remember, we do want a couple more points. And remember the method I used in the beginning, which was over 1 up 1? Well, in this problem, it would be over 1 up 3, because of the 3 leading coefficient. We already did that. Remember in the original problem, it was over 2 up 4. So in this problem, it's going to be over 2 up 3 times that. So over 2 up 12. And of course, I didn't really give myself enough space to do that. Oops, 12 is going to be way up there. So sorry about that. I didn't plan very well, did I? Okay, so we have our graph. We have the vertex, axis of symmetry, and y-intercept. It does say label, and that might imply you should write those on the graph itself, but I think we have them written near enough to the graph that it's fine. So let's take a look at number 5. And we also have a positive leading coefficient, so it's going to open up as well. If we put 0 in for x, we get our y-intercept, which is going to be the point 0, negative 3. For the axis of symmetry, we need the opposite of b over 2a, so that's going to be negative 1 over 1, so that's negative 1. So the axis of symmetry is the line x equals negative 1. And that means that the vertex will have an x-coordinate of negative 1. And we're going to substitute that into the function to find the y-coordinate. So 1/2 times negative 1 squared plus negative 1 minus 3. That should give us negative 3.5. So we can go ahead and draw our axes. Whoa, that one got out of control. Oh my goodness, I cannot draw a vertical line apparently. Okay, let's go with kind of the same scale we did last time, at least what I did, because my squares are so teeny tiny. So we have negative 1, negative 3.5. We have 0, negative 3. We can draw the axis of symmetry. We can reflect that other point across. And then if we think about our over 1 up 1 thing, it's not over 1 up 1, it's over 1 up 1/2 because of the 1/2 there. And it's not over 2 up 4, but it's over 2 up 2. So that would take us to here and reflect that across. And it's not going to be over 3 up 9, it's going to be over 3 up half of that, so over 3 up 4.5, which would take us to there. So even though we don't have to get that many points, if you can, might as well. It's just going to make the graph look better. Okay, there we have that one. We're going to do a couple more examples. This one says, tell whether each function has a minimum or maximum value. Then find that value. So remember, it depends on whether it opens up or down. And for number 6, we have a positive leading coefficient, so the parabola opens up. So the vertex is going to be the minimum point. And so this one has a minimum. And then to find the minimum, we need the y-coordinate of the vertex. So let's start by finding the x-coordinate of the vertex. And to find the x-coordinate, we use the opposite of b over 2a. And in this case, what's our b? We have an invisible 0x in there. So it's 0 over 18. So that's 0. And if we put 0 in for x, what do we get for the y-coordinate? We get 7. So the minimum value is 7. And then for number 7, notice that we have a negative leading coefficient, so this parabola opens down. So that means that the vertex is going to be at the maximum point. And to find that maximum, we need the y-coordinate of the vertex. So we start by finding the x-coordinate. Opposite of b over 2a is going to be negative 18 over negative 6, and that's 3. So if you substitute 3 into the equation, you end up with 22. So the maximum value is 22. Okay. Number 8. A woodland jumping mouse hops along a parabolic path given by this equation, where x is the mouse's horizontal position in feet and y is the corresponding height in feet. Can the mouse jump over a fence that is 3 feet high? So here's the ground, here's the fence, it's 3 feet high. Is the mouse doing this? Or is the mouse doing this? We're about to find out. What do we need to know? When you look at the equation, you notice there's a negative leading coefficient, so that tells you the parabola is opening down. You need to know the maximum point. You need to know the y-coordinate of the maximum and find out if it's above 3 feet or not. So let's go ahead and find that. So first, to find the x-coordinate of the maximum, we use the opposite of b over 2a, and that would be negative 1.3 over negative 0.4. Let's see if we can simplify that. I'm going to use my calculator, type in the decimal, and then press math, change to fraction, and it gives me 13/4. That's the x-coordinate of the point. We need the y-coordinate. So if we have negative 0.2 times 13/4 squared plus 1.3 times 13/4, I'm going to put that into my calculator. I'm not really that concerned about keeping it all exact with fractions. I just need to know whether or not it's more than 3. So I'm going to approximate it, and it turns out to be about 2.1. So what's our answer? Can the mouse jump over the fence? No, the mouse cannot. Okay, so here's our assignment. And there are a couple of evens, and because there's a lot of graphing and your book typically does not show all the answers for the graphing problems for whatever reason, I've uploaded an answer key for you that has the answers worked out to everything, and that way you can check all of your answers when you're done and when you're ready. Thanks, everybody.